In section 1.3, we're going to continue our discussion of a topic that we briefly started to talk about in the previous sections, specifically this idea of a sample. We talked about the difference between a population and a sample, where the population is everything you're studying, all the people, or all of the polar bears, or the list could go on and on. The thing that you're studying, everything that fits into that thing that you're studying. However, sometimes, well, let's be honest, more than just sometimes, most of the time, your population is way too big to be able to study every single member of the population. So we have to settle with samples, right? We have to select a smaller portion from the population and study the sample and hope that the sample gives us information about the population. Now, that brings us to one of the most important statements in statistics. It's a statement that statistics teachers have made countless times over many, many, many years. And it's this concept of without randomization, there can be no generalization. What we mean by that is this: if your sample is not selected in an appropriate way, your sample will not accurately represent your population. But our goal is that our sample does represent the population. So section 1.3 concerns itself with what are some methods that we can use to try to get a sample that mirrors or represents our population as good as possible. And the key to do that is this word right here, random. What we find is that the more randomized our method of selecting our sample is, the better it usually represents the population. There's other factors that go into it, such as the size of the sample. If we're looking at the entire United States, randomly, even if we're completely randomly selecting 2 people, not going to be very representative of the United States. But what if we're able to randomly select 2,000 people? Well, now we're getting somewhere in regards to those 2,000 people representing the whole United States. Will the characteristics of those 2,000 people be the same as the characteristics of the entire population? And that right there is the key. Do the characteristics of the sample match the characteristics of the population? And so we have several different tools at our disposal to make sure that our sample is random. So let's take a look at the few different ways that statisticians use to generate their samples to make sure that their sample is randomized and reflects the population as much as possible. Here's the first method that we have. It's called a systematic sample. A systematic sample is a sample obtained by selecting every kth member of the population, where k is a counting number. So let's just use this as an example. I have a list here of surnames. So we're saying that this list of 220 surnames is our full population. Okay. Now we're keeping the full population fairly small for the sake of example, because 220 is not that big of a population. But let's say we only have the time and the money to study a certain smaller proportion of these surnames. What if I want to randomly select, let's say, 20 of these? How would I randomly select 20 names from this list? Well, the systematic sample would say this: let's start at a random location. Now, if I want to select a sample of 20, what we're going to find out is the letter n, the lowercase n, is often in statistics used to represent your sample size. Okay, I want to select 20 names from this list. So what I'm going to do is I'm going to randomly select one of these names. But then what I'm going to do is I notice that I have 220 total names. Well, if my sample size is 20, well, how many times does 20 go in to 220? Well, if we do the math, I think we're going to find out that what goes in once, so 20, and then subtract 20, so that's 1 right there. It goes into it 11 times. So here's what we're going to do. This 11 right here is our value of k. So we're first going to start by randomly selecting a name, a surname in this list. And then what we're going to do is we're going to count off every 11. So every 11th name beyond the one we randomly select is going to be the next member of our sample that we're going to use. But the question is, how do I randomly select one of the surnames here? Well, let's do it this way. We've got one way of doing this. You can find this online as well. If you type in random number generator in Google or any other search engine, you'll find really quickly a website that'll help you generate a random number. You also have it in your TI calculator. Okay, so what I'm going to do is I'm going to hit my math button, and I'm going to go over to PRB, which stands for probability. And I'm going to come down here to option 5, which says randint. That means random integer. And I'm going to hit enter. And here's what I'm going to do. Randint, I'm going to hit 1, 220. You probably see what I'm doing here is, what this is going to do is, it's going to pick a random number between 1 and 220. So I'm going to hit enter, and it randomly selects 162. 162. So I'm going to go back to my list here, and I'm going to find the 167th surname. It's Winchester. Now, from this, like we said, if I want a sample size of 20 out of 220 total names, that means every 11th. So starting at the randomly selected one, I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You guys can see the concept that we're going for here. I'm going to at least work through the end so you can see what we do when we get to the end. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Well, now I'm at the end of my list, so I'm going to go 1, 2, 3, and then back to the beginning. 4, 5, 6, 7, 8, 9, 10, and 11. So again, we could keep doing this until we cycle through the entire list of surnames, and all of the names that we've selected are going to be what make up my sample. So that's the systematic sampling method. Let's look at another sampling method, stratified sampling. So stratified sampling is a sample obtained by dividing the population into subgroups or strata, according to some characteristic relevant to the study. There can be several subgroups. Then subjects are selected at random from each subgroup. So let's look at the population of the entire United States for our example. Okay? Now, the entire population of the United States is somewhere around 350 million people, right? So impossible to study or to gather information about every single person in a timely or cost-effective manner. So we want to select a sample of people from the United States. However, we want to make sure it's randomized so that it reflects the whole United States. So, because think about it this way, if all we did was poll people in Oregon, and you pick the topic, politics, opinion about social or cultural issues, opinions about preference related to food choices. The list can go on and on and on. Is Oregon representative of the United States? Probably not. Okay? And that goes for any state in the Union. However, here's what we're going to do. Okay? What we're going to do is we are going to split up the United States into strata or subgroups. Well, conveniently, the United States is split up into 50 strata already. Okay? And each strata has its own uniqueness, but as a whole, all the strata together combine to represent our population well. So here's what we're going to do. We're going to break it up into the 50 states. Right? And then what we're going to do is we're going to say, let's randomly select 100 people from each state. Right? And it can go on and on and on for all the different states, right? So if we randomly select 100 people from all the different states, 100 people times 50, right, 0, that's 5,000. Right? Okay, so finding 5,000 or polling or gathering information from 5,000 people, way easier than trying to gather information from 350 million people. But because we followed a stratified sampling method by taking our strata or the subgroups according to some characteristic relevant to the study, right? Maybe this is politics, and so the state you live in is a characteristic that is relevant to what you're studying, because every state has its own political leaning, right? And so we break it up into strata. We select a certain number from each strata, and then we hope that that method allows us to randomly select our sample in a way where the sample actually is reflective of the entire population. Okay, so that's the second method that we have at our disposal. Another way to picture this is if this box right here is our entire population, we break this box up into strata, broke it up into 8 different sections, and we randomly select individuals from each of these selections, maybe 10 from each of these strata, for a total sample size of 80. Right? So again, we're breaking it up into groups according to some specific characteristic. A really simple example of this, male-female. Right? We want accurate representation or equal representation, so I'm going to randomly select 50 males and 50 females to make sure I'm getting accurate representation. Okay. Next, we have what's called cluster sampling. A cluster sample is obtained by dividing the population into sections or clusters and then selecting one or more clusters at random and using all members in the cluster as the members of the sample. So this one is sort of similar to stratified sampling, but there are some key differences. Okay? Just like stratified sampling, we are going to break our population up into multiple groups. Instead of calling the groups strata, we're going to call them sections or clusters. Okay? So again, let's use the United States as our example. Conveniently, because the United States is made up of 50 states, obviously Hawaii and Alaska aren't reflected on this, but for sake of argument, we got the 50 states, and each state represents a cluster. But here's the difference. Instead of saying, let's randomly select a certain number of people from every single state, here's what it's saying. Let's randomly select a state or a group of states. Let's randomly select 3 states. So we're going to randomly select, and we get Nevada, we get, let's say, New York, and we get, let's do West Virginia. Okay, so we randomly select those. Now, the cluster sampling is interesting because depending on what you're studying, Cluster sampling can be helpful, or it can actually be harmful to generating a representative sample. Think about it this way. Let's start over. What if our study is a political study and we're collecting information about people's political opinion? What if, again, let's just select 3 random states. What if the 3 random states we select are, let's say, Florida, let's say Texas, and let's say Montana? Do you think if those 3 states are the ones randomly selected, you are going to get bias where the results are going to be different than if you look at the whole entire United States? Why? Well, because those 3 states are more conservative leaning. Is that fully representative of the entire United States? Probably not. Likewise, if the 3 random states selected are California, New York, and let's say Massachusetts, are those 3 states representative of the entire United States? Probably not. In the opposite direction, because those states are more liberal leaning. So cluster sampling, you have to be really careful about how you use it. But that's the concept. If you have a population broken down, right, into clusters, you randomly select a cluster. Maybe here's an example of where cluster sampling might be useful. Let's say along the Oregon coast, right? Along the Oregon coast, let's say that there's several there's studies that we want to do based off of a certain type of fish that lives in coral reef areas. Okay, so what we could do is we could say every coral reef area along the Oregon coast is a cluster, right? And we're going to randomly select a few of those clusters and study the fish at those coral reef, right? Okay, depending on what and how we're studying it, the fish in each of those coral reefs selected, right, may actually represent all of that type of fish in all of the coral reefs along the Oregon coast. Okay, so again, just another sampling method, but we have to still be careful how we use these sampling methods, because the goal always is to make sure our sample accurately reflects the population. 3 final notes here. Things to be aware of. A convenience sample is obtained when a researcher uses subjects who are convenient. Right? In other words, rather than randomizing, it's I'm going to just go gather information from subjects that are easy to get information from. Again, might not be very helpful. So example of that might be, let's say you want to study people's opinion on whether or not they like shopping at Costco. Right? Well, standing in front of Costco and asking people about their opinion of whether they like to shop at Costco as they come into Costco would be very convenient, but will that represent the population well? No, right? Because you're not getting information from people who aren't going to Costco, right? So that convenience sample is going to significantly skew the data. Sampling error is the difference between the results obtained from a sample and the results obtained from the population from which the sample was selected. This is what we're trying to minimize. Okay? We are trying to minimize the difference between our sample and our population. Okay? So sampling error is a result of selecting a sample that is not representative of our population. Lastly, this concept of non-sampling error. It occurs when the data are obtained erroneously, right, or the sample is biased, i.e. non-representative, right? Or for that matter, non-sampling error, here's connected with convenience sampling. Right, let's say we send out a mailer, right, to 100 people, right? And we ask them to fill out a survey about their opinion regarding a business in town and whether they think the business has provided good service or bad service, right? Of those 100 people that get that mailer, man, you're going to be lucky if 10 people respond. And those 10 people, right, usually people only respond if they really, really like it or they really, really hate it. Right? Everybody in the middle just doesn't care about taking the time to fill it out. Right? So you have 90 people that you didn't get information from out of the 100 that could differ significantly than the 10 people who feel strongly one way or the other and are actually motivated to take the time to reply. Right? So non-sampling error. So with that, this kind of wraps up our discussion in regards to sampling and things that we just need to be really careful of when it comes to how we collect our samples. But the key thing to remember in all of this is without randomization, there can be no generalization. That's going to come up when we get to hypothesis testing quite a bit.